Dear students, in previous video, we have learned that the sound can propagate from three mediums. That is, sound can travel through solid, liquid, and gas. In other words, we can say that the sound requires a medium to propagate. Sound travel through solid, liquid, and gases. Sound travel through the solid thread. For an example, solid travels through the solid thread of a CAN telephone. A whale listens to the reflected sound in water to locate its prey, and we are able to listen to sound because sound travels in air. Now today we are going to discuss how we are able to hear the sound and in what way we are able to hear the sound. The nature is provided us the ear. With the help of that we can easily hear the sound. If we just go through the structure of the ear, then we can find out this is the structure of a ear. The ear can be divided into the three parts. That is the number one part which it's shown, that is called the first part, which we call the outer ear. Then there is a part is called a middle ear, that is the second part, and third part here we have also got, that is called the inner ear. That means the ear has divided into three parts: outer ear, middle ear, and inner ear. Now how we are able to hear the sound? The shape of the outer part of the ear is like a funnel. That means that shape, that is, if you are comparing, that is the part which we are talking about. This is the structure of like a funnel. Funnel means funnel structure like this. This is the funnel, and that is the funnel structure. So that means the outer ear is like a funnel shaped structure. When sound enters it, it travels down a canal at the end of which there is a thin stretch membrane, and it is called the eardrum. This is called the canal, that is your inner canal, that is your outer portion of the ear. After that it is connected to a ear canal, and it is attached with a stretch membrane. There you can see that is the stretch membrane is there. It performs an important function. To understand what the eardrum does, let us do a tin can model of the eardrum. The eardrum is like a stretch rubber sheet. Sound vibrations make the eardrum vibrate. The eardrum sends the vibrations to the inner ear. From there, the signals goes to the brain, and that is how we are able to hear the sound. It means sound is entered from the outer ear, then moving through the inner canal, and after that ear canal, and it is vibrate the eardrum, and it is a stretch membrane like structure from where the sound vibrations are sent into the inner ear, and from inner ear the sound wave are sent to the brain, and there we can able to hear the sound. So if we again we want to summarize how we are able to hear the sound, then we can define like that: sound enter first, where sound enters the ear through the ear canal. It makes the eardrum vibrate. After that, what we are doing, the eardrum vibrate. The eardrum sends the vibrations to the inner ear. From there the signals go to the brain, and we are able to hear the sound. That is the mechanism by which we are able to hear the sound from the ear. So first of all, the sound is entered from the outer ear, through which it is moving into the ear canal. Then it vibrates the eardrum. That vibrations are transferred to the inner ear. From inner ear it is goes to the brain, and from where we are able to listen the sound. So that is the common mechanism by which a human, with the help of human ear, we can hear the sound very easily. Now we will go through what is the structure, what is the basic structure, and what are the other names of the different part of the ear. The outer ear are called the pinna. The name has given is called the pinna, which collects the sound waves. The sound wave passes through the ear canal, that is the ear canal again. This is the ear canal, to a thin membrane called the eardrum. There is a thin membrane is there which is called the eardrum. The eardrum vibrates the vibrations are amplified. Amplified means it can be multiplied. That means it is become more. By these bones of the middle are called the hammer, anvil, and stirrup. If we look out the what are the name of the bones, that is the middle ear, and it has given the names, that is the hammer, anvil, and stirrup. These all three bones are collectively made the middle ear. That is called the middle ear. In middle ear, what are the names of the bones we have got? Hammer, anvil, and stirrup. The middle ear then transfers the sound waves to the inner ear. That is, after that sound waves are transferred to the inner ear. In the inner ear, the sound waves are converted into electrical signals. That is a very important thing, that whatever the things we have sensed, either we have seen, smell, listen, seen, taste, all these things have been converted into the electrical signals, and then only the brain can easily sense, or we can say that easily detect the different senses. So the hearing is also another sense, so that can also be detected by the brain by the electrical signals. So in inner ear, the sound waves are converted into electrical signals by the cochlea. That is the name, that is called the cochlea, that is inner ear, where a fluid is filled. There you can see there is snail like structure is there. That is the snail like structure is there, that is known to be the cochlea, in which a fluid is filled in it. So that the signals which is coming from the middle ear to the inner ear, the vibrations are converted into the electrical signals and sent to the brain through auditory nerves. That means from inner ear, the auditory nerves are connected, and the brain then interpretate the signals as a sound. So that is the basic structure how we are able to hear the sound. So basically the ear is divided into the three parts: outer ear, middle ear, and inner ear. Outer ear is collecting the sound waves, then it is transferred to the ear canal into the middle ear, where middle ear we have got the three bones, which namely they are hammer, anvil, and stirrup. They are just transmitting these sound waves, amplified these sound wave, transferred to the inner ear, where inner ear have a cochlea, the snail like structure. After that it is transferred to the from there it is transferred into electrical signals, and then it sends to the brain by the auditory nerves, and from there brain can easily detect the sound waves. There is the structure, if you are going through, this is called the pinna, that is your in ear canal. There you can find out there is a eardrum, that is also indicating that is your eardrum. There are the three bones: stirrup, hammer, and and we can have the three bones, that is hammer, anvil, and stirrup. There are the three bones: stirrup, anvil, and hammer. They are transmitted the wave into the ear, that is your cochlea. From there it can be transferred and we can easily hear the sound. That is the structure there is in a eardrum, and inner ear has shown to us. Now we will go through an activity, and in which we try to understand how the eardrum is functioning, that how we are able our eardrum is functioning. That means eardrum is like a stretch membrane. For that we had to perform an activity like it has shown into the figure. We have to required a stretched membrane, like we have required a rubber balloon, and we have required a plastic tin can. There you can see that we have got a one plastic cane, and we have required a stretched balloon sheet. First of all, what we trying to do, we had to take a plastic or tin can, cut its ends. That means we had to be open from both the ends, like it has shown. That is, if we are cut it down, and if we are just making both the ends is open, At one end, what we do, we stretched a piece of rubber balloon. We have stretched a piece of rubber balloon across a one end of the can and fasten it with the rubber band. Put 4 or 5 grains of the grain of dry cereals on the stretched rubbers. Now ask now what we are going to do, we ask our friend to speak hooray hooray from the open end like it has shown into the figure. That is the structure. We have taken a tin can, we have opened both the ends, we stretch the rubber balloon and fasten with the help of the rubber band. After that we are just taking 4 or 5 cereal grains, and after that we just say our friend that it can speak louder at the other end of the can. Then we can find that these cereal grains are jumping on its place. That means that cereal grains are jumping from its place and come down. As soon as we speak loudly, then these grains are moving in upward direction. As you can see in the first and second picture, if you're comparing, if you just compare the first picture, then the grains are at settle down at the rubber sheet. When we try to speak loudly, then you can see that these grains are jump into the air, and as we stop speaking in it, then again it settle down on the rubber sheet. So in that way, that the eardrum is functioning, and that is the processor by which that eardrum is functioning. In a similar manner, the eardrum of our human ear is also got vibrated when the sound waves are entering into our ears. Speed of a sound. Speed of a sound depends on the elasticity. That is the first thing on which the speed of a sound is depend. That is called the elasticity. The ability of an object or material to resume its normal shape after being stretched or compressed. That is called the elasticity. The ability of an object or a material to resume its normal shape after being stretched or compressed. Like the eardrum is stretched and compressed. The density of the medium through which it propagates. The second property is the density of the medium through which it propagates. Like sound is traveled through solid, liquid and gas. In case of air, it also depends upon the temperature of the air. The speed of a sound through the air is about 330 meter per second. The speed of a sound through the water is 1500 meter per second. The speed of a sound can be described like this. That means the speed of a sound is maximum in sound solid, then it has its speed in liquid and gases. That means the speed of a sound is maximum in solid and it is minimum in gases. And speed of a sound is depend upon mostly the three factor. First is called elasticity, second is called the density of the medium, and third is called the temperature of the air. And in air, the speed of the sound is 330 meter per second, whereas in water it is about 1500 meter per second. The speed of the sound is maximum in solid and speed of the sound is minimum in gases, or you can say it is least into the air. Now there is a table is also given to us. There are the three different medium has given to us: solid, liquid and gases. If we are just go through it, then we can find out in solid the highest speed it is indicating is 5960. That means if you are going through 5960 is 6420. These are the numbers as shown to us. If we go through that then we can find out that in solids the highest speed from which substance, from the aluminum, the speed of the sound is highest into the aluminum. It is about 6420 meter per second. Whereas if we are talking about the liquids, then in liquids the water, the seawater, especially the seawater has got the highest speed, that is 1531. meter per second. And in gases, the hydrogen gas is the name of the gas in which it has got the highest speed, and that is the highest speed has given 1284 meter per second. So if we are going through the table and identify from which substance the speed of sound is maximum, then we can find that the speed of sound is maximum in aluminium, than in water, and in gases it has got the in hydrogen. In solids, in this table, aluminium has got the highest speed of sound. In liquids, seawater has got the highest speed of the sound, and in gases, the hydrogen gas has the maximum speed of a sound. Now, there is an interesting thing is that what are the difference between the speed of light versus the sound. That means the speed of light is more as compared to the speed of sound. Here it has given to us the speed of a sound is about 330 meter per second. What we have given, there is the speed of a sound in air is about 330 meter per second, whereas the speed of light in air is about 3 into 10 to the power 8 meter per second. Speed of light is faster than the speed of sound. That is why the thundering sound are always heard a little after seeing the flash of lightning. Both lightning and thundering occur together. Delay in the hearing is due to the difference in the speed of sound and speed of light. There has question always asked that why we are able to see the flash of light first, then we are able to hear the sound later, in especially in thundering and lightning. The answer is because there is a difference between the speed of light and speed of sound. The speed of sound in air is 330 meter per second, whereas the speed of light in air is about 3 into 10 raised to power 8 meter per second. Due to that, because speed of light is faster than the sound, that's why in a case of thundering and lightning, we have seen the flash of light first and we hear the sound later. Now there are some terminologies are associated with this, and these terminologies are vibrations, oscillation, frequency of a sound wave, and time period of a sound wave, and amplitude of a sound wave. How we are able to define that? Vibrations, from this is the picture of a simple pendulum by which we can easily identify what are the definitions are there. Vibration is the to and fro or back and forth motion of an object, and vibration is also called the oscillatory motion. As you can see in the picture, there is a simple pendulum. We have shown the three positions A, O, B. O is called its original position. A and B are called the extreme position. When we are release the simple pendulum from position A, then it moves from A to B and it has come back from B to A. That is called to and fro motion. And I also told to you that if there is a spring block combination is there, that is the spring, and we are attaching a block to it and we try to compress or stretch. If we try to compress it then and release it, then this block is also moving back and forth motion. That motion is also known to be as the vibration of spring block system, and in simple pendulum also to and fro motion is called its vibration or oscillatory motion. The motion of the pendulum from one extreme position to other extreme position and back is called the oscillation, like from A to B and again it is come back from B to A. Now, what is a frequency? The frequency is, we have already learned about what is the oscillatory motion or vibration. Now the frequency is defined as the number of oscillation per second is called its frequency. It means in 1 second how many times this vibration has been completed. Suppose from A to B and from B to A, that is called one vibration. Then we have, suppose we have to count the number of vibrations. Suppose in 1 second, if simple pendulum is doing 5 vibrations, then it is called, its frequency is 5. If this pendulum is covered 10 vibrations, then it is called its frequency is called 10. The SI unit of the frequency is called hertz. That is the unit of frequency, and that is called hertz. And it is represented by a symbol. That symbol is shows to us, and that is called nu. It is make like this. This is the symbol of frequency. So what is the definition of frequency? Frequency is nothing but it is the number of oscillation or vibrations per second is called its frequency. Its SI units, its hertz, and it is represented by nu, and it is represented like it is. This is the symbols which we call the nu and nu. Time period. Time period means the time taken for one oscillation is called the time period. That means how much time is consumed by the simple pendulum or a vibrating body is known to be as its time period. Like means if we release from A, it move A to B and again return back from B to A. Then whatever the time is taken by this simple pendulum is called its time period. It is represented by T. That means it's represented by capital T. The SI unit is seconds. Frequency and time are represented like this. That means there is a relation between the time period and frequency. That is the formula. That means the time period is equals to 1 upon frequency. That means if we are saying then the time period is equals to 1 upon frequency. This is the relation between the time period and frequency. Or in another word, we can say that the time period is the reciprocal of the frequency. If we are going through that formula, then we can say that the time period is the reciprocal of the frequency. That means time period is equals to 1 upon frequency, or frequency is equals to 1 upon time period. That is known to be the time period of a sound wave. Next is amplitude of a sound wave. The maximum displacement. How in earlier video I have also told you what is an amplitude. Now again from with the help of simple pendulum we are defining the definition of amplitude. The maximum displacement of an oscillating or vibrating body from its central position is called its amplitude. Here if we are going through the situation of simple pendulum, then we have got the two position A, B from its original position O. If we are just make these line, that means OA and OB, these are the two lines, OB or OA. These are known to be as the amplitude of this simple pendulum. This distance is known to be as the amplitude of the simple pendulum. Basically the waves can be represented by like this. This is the representation of the sound waves, and that is a type of graph which is in between the density of the medium versus the time, or you can say that in a pressure and pressure versus, this is a type of graph which is we have represented here. As you can see that what is an amplitude? Amplitude is nothing but this distance. This is the distance which shows, this is the distance from its original position. This line is called original position, and these curves are known to be the different position, and that is known to be the gap between them. This gap is known to be the amplitude of the sound wave. The amplitude of a sound wave is the height of the crust and turf. Here what is a crust and what is the turf? That is in picture. If we are going through these curves, that means the upper curves are called the crust and the lower curves are known to be as a turf. Upper peaks of the graph is called the crust and lower peaks of the curve is known to be as a turf, and it is represented by a amplitude is represented by capital A. The SI unit is the same as the density or pressure. That means the SI unit of the pressure or density is same. So we have learned about that in force and pressure, the SI unit of the pressure is Newton per meter square. In a similar manner, the SI unit of the amplitude is also Newton per meter square. So the maximum displacement of a vibrating body from its original position or central position is called its amplitude. Now there is another question is arises, what is the loudness and pitch of sound? That means there is a difference between what is pitch, which is also called the shrillness of a sound or flatness of the sound, and the loudness, that means how loud we are able to speak. The loudness of a sound and shrillness of a sound can easily be understood by the examples like the sound of a drum and sound of a whistle. The sound of a drum is much more louder as compared to the sound produced by the whistle. The loudness of a sound depends upon the amplitude of the vibrations. That means this is the amplitude. That means if a person has got more loudness, then its amplitude is more, and we have already discussed what is an amplitude. It is the maximum displacement of a vibrating body from its central position is known to be its loudness. That means sound wave, if we are try to make the sound waves of a drum, then it will be make like this is the sound waves of a drum, whereas we have got the sound wave of whistles very small, where if we are going to draw the curve of a drum, then we have got the bigger curve, and for whistle we have got the very thin waves. If the amplitude is less, then the sound is feeble, that means very low sound. If the amplitude is more, then the sound is very loud. The unit of loudness is decibel. We can measure the loudness into decibel. What is a pitch or shrillness of a sound? The pitch of a sound depends on the frequency of a vibrating body. That means number of vibration in 1 second is known to be the frequency. If the frequency is less, the sound has low pitch. If the frequency, like low pitch means sound of a drum, sound of an adult, that means sound of an adult and sound of a drum is considered to be the low pitch sound, whereas the sound of a whistle or sound of a baby is very shrill. That means the pitch of the baby is very high. That means if you are going through the sound of a whistle or a sound of a baby, then they have got very high pitch sound, or we can say that their frequency is very high. So the loudness and pitch both are depend upon the two fundamental characteristic of the sound wave, that is called the amplitude and frequency. In case of loudness, the loudness is depend upon the amplitude, and in case of a pitch of a sound, it depends on its frequency. If we say a person has got the low frequency, that means it has got the more loudness, whereas if we say that a person has got the high pitch, then its loudness is decreases. Or in another words, we can say that the loudness is directly proportional to the amplitude and pitch is directly proportional to the frequency, and both loudness and pitch are opposite to each other. That means if loudness is more, then the pitch is low, and if pitch is high, then the loudness is low. That means both are opposite to each other. That means if loudness is increases, then pitch is decreases, and if loudness is decreases, then pitch is increases. In that way, we can easily understand the concept of loudness and pitch of sound. Now, we are going through that there are the variety of sounds are available in our surrounding, and that can be defined into two categories: audible and inaudible sound. So what is an audible sound? All the sound waves are represented by its hertz. Audible sound. It is a sound we can hear. It has a frequency from 20 hertz to 20,000 hertz. That is the range in which we can hear the sound. There is another category, inaudible sound. Inaudible sound which we cannot be hear. That is called inaudible sound. It has frequency less than the 20 hertz and more than the 20,000 hertz. That means inaudible frequency which is less than 20 hertz and more than 20,000 hertz, that cannot be heard by us. So the sound whose frequencies are more than 20,000 hertz are called the ultrasonic sounds. Some animals like dogs can hear the ultrasonic sound. Bats are produce the ultrasonic sound. That means dogs are able to hear that sound and bats are produce that particular sound. This is called the audible and inaudible sound. The range of hearing. Human beings can hear sound frequency between 20 hertz to 20,000 hertz. Sound whose frequency is less than 20,000 hertz is called infrasonic sound. Animals like dogs, elephant, rhinos, whales, etc. produce and hear the infrasonic sound. The sound whose frequency is more than 20,000 hertz, it's called more than the 20,000 hertz, it's called the ultrasonic sound. Less than the 20 hertz, it's called the infrasonic sound, and more than the 20,000 hertz, it's called the ultrasonic sounds. Animals like dolphin, bats, rats are produce the ultrasonic sound. Bats are reflection of ultrasonic sound waves to detect an obstacle or its prey. So we can say that we have divided the sound into two categories: audible and inaudible. Audible 20 hertz to 20,000 hertz. If the sound wave is less than 20 hertz, it's called infrasonic, and it is more than 20,000 hertz, then it is called the ultrasonic sound. Now we have come, there is a point is known to be the noise and musical sound. What is a noise? Unpleasant sound are called the noise, and it is produced by the irregular or non-periodic vibration. For example, if the student in a classroom speak together, that is creating a noise. Sound produced by the horns or buses and trucks, they all are considered to be as a noise. What is musical sound? Sound which is pleasing to our ears, that is called the musical sound. It is produced by the regular or periodic vibrations. Sounds are produced by the musical instruments. Sound of a person singing a song, that is also come into the category of the musical sound. These are the example. Both these are examples of noise, and both these are example of music. If there is a periodic or regular sound wave, it is called music, and if there is a irregular or non-periodic vibration, then it is known to be as the noise. That is known to be as a noise. So if we are going through that, then we can easily find out that there are the basic definitions like the vibrations, how we are able to hear the sound, time period, frequency, the range of audible and inaudible sound, and how we are able to categorize these range of hearing. They all are defined into the terms, and that is known to be the unit which we are using. It is called the hertz. So in this video we have learned about that how we are able to hear the sound, some fundamental characteristic of a sound waves like time period, frequency, amplitude, vibrations or oscillations, frequency, loudness, pitch, range of hearing, audible, inaudible sound, noise, and musical sound. There is a relationship between that, how we are able to learn that the time period is equals to 1 upon frequency. That is the formula which we have learned, that time period and frequency are interrelated to each other. In similar manner, the loudness is also related to each other, in which we can say that the loudness and pitch is also opposite to each other. If one is increases, then another is decreases. And there is a noise and musical sound. I hope you understand this. Thank you very much.